This is Bob Capetta from the College of the Florida Keys. And this is a Calculus 1 Test 2 review lesson focusing on related rates. So let's take a look at what we have here. So the example I'm going to start with is the following equation. Y equals 3x squared plus 5. We want to find dy dt. When x equals 2. Given that dx dt is -4, when x equals 2. So here's our process. We're going to take the derivative with respect to t of both sides. The derivative with respect to t of y is going to equal the derivative with respect to t of 3x squared plus the derivative with respect to t of 5. The derivative with respect to t of y is dy dt. The derivative with respect to t of 3x squared is 6x dx dt. Plus the derivative with respect to t of 5 is just 0. Now our goal is to find dy dt. We're told that x is 2. Normally speaking, I would plug that 2 in to solve for y, but I don't really need it here. So I can solve it in a straightforward manner and say dy dt is 6 when x is 2, and dx dt is -4, so that we get dy dt is 12 times -4 is -48. Of course, they're all not that easy. Sometimes these get a little bit more challenging. So let's take a look at another problem. This time we will say the radius of a sphere is increasing at a rate of 3 inches per minute. Find the rate of volume when R is 6. So find the rate of change of volume. When the radius is 6 inches. So if that's the case, we need a formula that's going to relate the volume to the radius of a sphere. So we will say volume V is 4/3 pi r cubed. We're going to take the derivative with respect to t of both sides. ddt of V is ddt of 4/3 pi r cubed. Now 4/3 pi is a constant that can be pulled out front. So ddt of V is 4/3 pi ddt of r cubed. ddt of V is dv dt equals 4/3 pi. ddt of r cubed is 3r squared dr dt. Then we continue with this, we get dv dt is what? The 3's cancel, I get 4 pi r squared dr dt. So that's nice. Now we want to find the rate of change of volume when R is 6 inches. So we're told find R is 6 inches. We're also told the rate of change of the radius is 3 inches per minute. So dr dt is 3 inches per minute. So if we plug all this in, we have this formula here, dv dt equals 4 pi r squared dr dt. So we'll say dv dt equals 4 pi r squared would be 6 inches times 6 inches. 6 inches squared times the r dt, which is 3 inches per minute. Just take a quick look at the units here. Inches, inches, inches. It's inches cubed. So we get dv dt is 4 pi times 6 squared times 36 times 3 cubic inches per minute. So we put all this together. We get dv dt is approximately 4 times pi times 36 times 3, about 1,360 cubic inches per minute. So that's that one. Let's go ahead and do one more of those related rates problems here. Let us take a look at the following. We're going to say that an airplane flies at an altitude of 5 miles. An airplane flies at an altitude of 5 miles. Toward a point directly over an observer. The speed of the plane is 600 miles per hour. Find the rate of change of the angle of elevation theta. When theta is pi over 6. So let's make sure we have a picture. We have a person. We have a plane coming this way. The height of the plane is constant, is 5 miles. The angle of elevation here is theta. We want to see how much that's changing. Now, the plane is flying at a speed of 600 miles per hour. So if I call this x, what we have here is x is getting smaller, x is shrinking. So dx dt is actually negative 600 miles per hour. So we'll go ahead and write that down, and that's constant. Dx dt is negative 600 miles per hour. Now, how do we relate these guys? Well, you'll notice I have 5 and I have x. I have opposite and I have adjacent. So relating x and theta, I will do that with either tangent or cotangent. So I will say tangent of theta is 5 over x. Or even better yet, cotangent theta is x over 5. Then let's take the partial, should be the derivative with respect to t of both sides. So the derivative with respect to t of cotan theta is the derivative with respect to t of x over 5. The derivative with respect to t of cotangent theta would be negative cosecant squared theta d theta dt. So negative cosecant squared theta d theta dt equals 1/5 dx dt. And our goal is to solve for d theta dt. Our theta here is pi over 6. So we will say negative cosecant squared of pi over 6 times d theta dt equals 1/5 dx dt, which is 1/5 of negative 600. 1/5 of negative 600 is negative 120. Cosecant reciprocal of sine of pi over 6 is a half. So cosecant of pi over 6 is reciprocal of a half is 2. Square it, I get 4. So I have negative 120 on the right side, and I have negative 4 d theta dt on the left side. Dividing both sides by negative 4, I get d theta dt is 30. And what are my units here? My units here are going to be radians per hour. And that will conclude this lesson.